like the top left is Almas and Petronas Tower, and the most inclined building as of now in the world, Capital Gate in Abu Dhabi, and Tornado Tower in Qatar, and of course Al Shams. All these structures have been constructed in composite structures, mainly by taking columns either as encased column or as say with concrete filled in tubes, and as of course the beams are being steel and the metal decking are being used for the decking system, where we have eliminated the formworks. And if you take Rose Rota, in terms of hotels, we have taken up Rose Rota on your right, on your left, the last, which is 75-story building in Dubai, and the middle one is Kingdom Trade Center in Saudi Arabia, which is also a hotel, and of course the last one is the Burj Al Arab, is also a 7-star hotel made up in a man-made island. All are being used extensively with structural steel. And in terms of convention centers, if you take Putrajaya Convention Center in Malaysia, which is almost 105-meter unsupported long span structure, and in fact the designers have done the design based on our erection methodology. So that is the way it has been constructed. And in terms of malls, if you take, we have Dubai Mall, which is 1 kilometer by 1 kilometer mall in Dubai in terms of sizes, and also the Mall of Emirates, which has Arabians' lateral thinking, where they have brought in Switzerland inside by having the skiing inside the middle of the desert, where 24 hours round the clock you have all the time 1.5 meter depth ice is always being maintained, and the people will be skiing there. And in terms of hospitals, we are right now doing a hospital in Abu Dhabi, which is Cleveland Clinic, which has 15,000 metric tons of structural steel involved inside, which has large span structures to take care of. It is not the strength governing structure, especially here the vibration governs in this particular case. And how are they in sense is a commercial building is driven by, if you take, based on the extensive analysis on various buildings which we have constructed as well as across the world, which is mainly meeting the architectural demand. Most of the structures on commercial things are involved, not in India. India, there are structures which are coming in, where, say, here, most of the concentration is on iconic structures, where like the Capital Gate, which is the most inclined structures, which we are going to see a few slides of that, how it is getting constructed. So those things are all really, really challenging, and it is possible only by constructing in steel, and RCC definitely would not have been possible. In terms of span, the major governing fact, as what earlier Mr. Turner has said, the long span structures, if you take, the obvious choice is structural steel, and as a commercial building, long span structures are very much useful in terms of modules of the the office modules, which can be multiples, where instead of 9 meter, if they go to 12 meter or they go to 15 meters, they have a very efficient usage of the space. So column-free structures is really, really advisable, and commercial buildings are mainly going into that area and the choice is structural steel as an obvious choice. And in terms of rapid business expansion, where number of buildings are getting up, and quick delivery and easy occupation because of the quick delivery, all these things that is again related to timing. So the structural steel construction is almost half or maybe 3/4 of the construction of the concrete buildings. And also like mega events, if suppose if the country is undergoing an event like Olympics or Asia or FIFA, if you ask, Qatar 2022 is completely being equipped, or maybe they're gearing up with the structural steel buildings, stadiums, everything. So which in fact Qatar 2022, the speciality is all this 9 stadiums which they are constructing right now, is after the event is finished, they are going to completely dismantle and going to give those stadiums at free of cost to the third world countries. So that is their one of the main topic for winning the FIFA 2022, and also Commonwealth Games. So these kind of events also can influence the commercial buildings in terms of structural steel. And off-site fabrication, because that avoids the site congestion. And if you take Mumbai, where the site is going to be a major constraint, even there are towers which right now we are doing, which is 20 meter by 30 meter, only the size of the tower, and we need to have almost about 8 meter excavation, and then we have to construct the raft and then proceed. So where the obvious choice is structural steel. In terms of flexibility, because the towers can be done either vertically, you can add up 2 floors if the FSI, because every chief minister when comes in the FSI changes and the number of floors goes up and down. So actually speaking, structural steel is one of the options where you can even just add up additional plates if it required at the bottommost layers if you are raising up based on to increase the FSI. In terms of horizontal attachment also can be done with the structural steel option comparing with concrete. And the building being lighter when you are using structural steel, as earlier been presented, you know that how the column sizes have been reduced, which in turn influences also the foundation. And as an office building or a commercial building, the transfer or the open space is really required. For example, most of the buildings are being constructed with facade as concrete, as glass, so which may not be possible in terms of residential building. So in terms of commercial building, to go to that stage, structural steel plays a major role, because lots of cantilevering is possible here. And also the fabricators with the state-of-art facilities who can do complete prefabrication outside, and they can bring it to the structures. And also the mindset, which is also a major area where right now still that we are not in a position to penetrate into the higher level in terms of residential building, in terms of structural steel. So these are the governing areas which we can foresee that the structural steel plays a major influence on the commercial buildings. And if you go back to, back to the projects which we have done, which is Capitol Gate. This is the most inclined building as of now in the world, which is a 33-story building and having almost about 9,000 metric tons involved inside, where externally it has been constructed with diagrids, and internally also been with an atrium opening up from 14th floor to 33rd floor, which is also constructed with pipe structures inside. So very highly challenging structure. If you see the flow plate, or in other, you see the pizza is about 14 degrees, whereas this goes to 80 degrees, and it is right now being registered as one of the world inclined one in the Book of Guinness Records. So if you see here, you can see that how exactly the core is being constructed. Core never have been inclined; it is vertical. Whereas at the bottommost point, the core and the structural steel diagrid is almost closer, where you cannot even have a usage space. Whereas on the other side, it is about 33 meter going outwards. The same way when in middle it is balancing, and at the topmost point, same case as reverse, where the core and the structural steel diagrid is very closer, whereas it is cantilevering on the opposite side by 33 meters. So when we are doing this, in fact core itself have been pre-cambered. If you ask me, they have moved the core by 330 mm, and it has been pre-stressed to take care of the counterweight when it goes up the top. So that is the way it has been designed. And if you see, complete Tekla model has been done by us on that. And if you see that it is one of the deck, which is the middle area. And this is the external diagrid alone, which is being done with the box sections at the base, 900 by 900 box of 80 mm thick built up sections. And when it goes to the top, the thickness reduces, the box size remains same, and it has gone up to 16 mm. And this is the actual structure which is constructed. And if you see the connections, any junction if you take, all the diagrams, there is no one single diagram is symmetrical. All the diagrams, all the junctions are different. When it takes as a surface, there is no single plane meets also the other plane. That is the reason we have introduced the cruciform plates which is in the middle to take care of the forces. So that is the way it has been done. So, and it is not really possible when you do that in concrete. And if you take the internal diagram, it is completely being done in pipes. And we have erected in segments like X, so that we just always face the pipe to pipe junction as perpendicular to that for easy construction at the job site. Because of the architectural reason, the entire jointed site is being done with welding. None of the areas the bolting is allowed. And we have at any point of time more than 30 plus welders who are highly qualified 6G welders in the job site to do the job. And this is just progress of that. And this is the inner atrium which starts from 14th floor up to 33rd floor. It is open. So inside of the office you can see the direct sun at any point of time on the middle of the building. And of course the other structures is also there, which is also strengthening the core and cantilevering. You see that at the middle there is a cantilevering portion there, which is nothing but, this is the topmost portion at 33 meters. If you see that extreme left edge is the place where the core is there, and it is getting cantilevered due to the inclination. And you can see that core with the jump form now. And where you can see that the cantilevering is happening, which is nothing but the swimming pool which they have done in the middle of the building, outside the building. And this is the progress of the project. The entire project with 9,000 plus tons have been done in 24 months, inclusive of our design. And here the major challenging thing is the design, detailing, fabrication as well as erection, all have been done simultaneously with just one or two floors in say up and down because of the geometry. Because when it goes up, the behavior of the structure has been taken up, and then as-built have been taken up when they do the reanalysis, and they will keep on doing that because the behavior of the structure, there is no symmetry there. Even it is not a circle, if it is not also an ellipse. So they were doing very closely with the construction team. So this is a structural steel building which I can say that one of the marvelous structure in Abu Dhabi, which is there on the main road. That is what the swimming pool which you are seeing on the middle. And in fact, glazing has a tolerance of more than 75 mm because when we are erecting, say for example 15th floor, when we are going up at say 30th floor, the 15th floor is not in the same position as what we have erected. So the tolerance which they are following with the glazing is very heavy. It is not even 5 mm or 10 mm like any other building. The tolerance has been very high and it has been accounted for 75 mm. So this is one of the structure which has a very good office usage space in terms of structural steel. Burj Al Arab, of course, you might be knowing that, which is a 7-star hotel access in terms of land, land, sea and air possible, and it is being done in the man-made island. The entire structure, as a structure it is in concrete, but the stability of the structure which is completely with the exoskeleton, and it is done only in steel. So outside, whatever that you are seeing as a curved member and diagonal member and horizontal member, all the members are just to make the structure stable. So this is the construction of the piece, and any point of time the piece weight what we have lifted is 25 tons. All are being prefabricated. And whatever that you are seeing on the middle is the scaffolding or the welding chair where the people have access there and welded. The entire structure is being welded in position. Because of the architectural reason, the bolts are not allowed, or it is being boxed. The bolt itself is very difficult to put up a joint there. So that is another challenging job, and it was the very first job for us in Middle East, and also for the UAE itself is the very first job to have its own challenges. And the diagonal which you have seen, that which you are going to see, has been erected with this transjacking method by cantilevering outside the building. The weight of the structure, weight of the diagonal is about 180 tons, and the length is more than 3-4 trailers, and it has been transported as a single piece in the entire, from the factory to the site. You see this, what you are seeing here is in the ground position, and that structure is being not assembled in the job site. It is being transported as one piece with the longest trailer, and when they were transporting, the speed of the trailer is about 5 km per hour, not more than that. So, and this is just in the lifting point, lifting condition. You can see that the pin, which is a single pin, the entire diameter of the pin is about 500 mm diameter, and it is, when it is getting inserted, it should not, in fact we have calculated the thermal expansion of the entire diagonal as well. And this is the erected point. And it is 3 diagonals on either sides. It's about, in total about 6. And the horizontal member itself is about 200 tons, which is being lifted again in the same methodology as the box. And what you are now seeing is the cantilever hotel, which is constructed on the same building with a segmental erection. You can see that the cantilevering is happening in the air. This is the under view of the same hotel, which is the Sky View Restaurant. It is about 70 by 25 meter size. And this is a helipad, which is about 200 plus tons, where the Andregas played the tennis over that particular helipad. So this is another structure which is